Right, this is Trig word problems, the second one. So this was from in class on Wednesday, March 6th. Okay, we skipped number 1. Okay, it's a little confusing. I think you could interpret it a couple different ways. So we skipped number 1. So we went straight to number 2. So we want to find this one's saying so for all these word problems, what we want to do first is read it once. And then the second time we read it, we want to draw it as we go along. So I think that's the best strategy for these problems. So number 2, we have from a horizontal distance of 80 meters, the angle of elevation to the top of the flagpole is 18 degrees. Calculate the height of the flagpole to the nearest tenth of a meter. Spelled the British way for some reason. It wasn't a mistake because they're all spelled the British way. All right. So horizontal distance is 80. Okay. So the angle of elevation to the top of the flagpole. So here's our flagpole. Okay. Angle of elevation meaning angle of elevation. Elevation meaning up, right? An elevator goes up. I guess it goes down too, but elevate, right? Lift up. So angle of elevation is this one. So that's going to be 18 degrees. Here's our right triangle. All right, so we have, let me write in blue though. Okay. And then it wants us to find the height of the flagpole. I still don't think if I write here. No, you can see it better, I think. All right. So we're finding a side. So we have one angle and one side, and we have to find another side. So we're probably going to use trig functions here. So let's label it. So this is our hypotenuse up here. So here's the angle we're looking at. X is opposite, 80 is next to, so that is adjacent. If we have opposite and adjacent, that means we're going to use tangent. So this is tangent of 18 is going to equal opposite over adjacent, so x over 80. Okay, we want to multiply both sides by 80. So if we multiply both sides by 80, okay, we're going to have 80 times the tangent of 18. 80 times the tangent of 18 is going to round up to 26.0 degrees. Okay. Number 2, a 9-meter ladder rests against the side of a wall. The bottom of the ladder is 1.5 meters from the base of the wall. Determine the measure of the angle between the ladder and the ground to the nearest degree. So here we have a wall. The ladder is going to lean against it. So again, the way I'm saying for you guys, the best way to do this is to visualize in real life. Visualize at your house a ladder going against the wall, right? You put the ladder up on the outside of your house against the wall. So that's what's going at the angle. Okay, ladder against the wall. The bottom of the ladder is 1.5 meters from the base of the wall. So the bottom of the ladder is 1.5 away. Okay, we knew the ladder was 9 meters long. Okay. It's 1.5 meters away from the wall. The base, determine the measure of the angle between the ladder and the ground. So here's the ground, here's the ladder, so we want to find this angle. We'll call it x. Okay, for solving for an angle, we're using the inverse trig functions. So here, again, let's label our parts. So this is hypotenuse. Okay, this down here is adjacent because it's next to the angle in question. Okay, so if we have hypotenuse and adjacent, we're going to use cosine. We're solving for an angle, so it's inverse cosine. So inverse cosine and adjacent over hypotenuse. So 1.5 over 9 is going to equal our angle, which we said was x. So the inverse cosine, 1.5 divided by 9, we get 80.4 degrees. So the angle x is 80.4 degrees. Okay. Number 4. Okay, number 4. The angle of elevation of the sun is 68 degrees. So if angle of elevation of the sun is 68 8 degrees when a tree casts a shadow that is 14.3 meters long. So again, shadows on the ground. How tall is the tree? So here's our tree. Okay. And here is our right angle. So the shadow, here's the sun up here. Okay. It's coming down, and the shadow is going to be 14.3 meters long, and it's forming an angle of elevation of 68 degrees. So angle of elevation is the angle going up, and we want to find the height of the tree. So we'll call that x. So here's our right triangle. Okay, hypotenuse is this length here. X is across from 68, so that's going to be opposite. 14.3 is next to 68 degrees, so that's going to be adjacent. So if we have opposite and adjacent, we want to use tangent. We're finding a side, so it's just the regular tangent. So tangent of 68 is going to equal opposite over adjacent, so that's x over 14.3. We have to get x by itself, so we need to multiply both sides by 14.3. Okay, 14.3. These cancel out. We get 14.3 times the tangent of 68 is going to be equal to x. So 14.3 times the tangent of 68. We're going to get 35.3937, so it's going to round to 35.4 degrees. These are, it's not degrees, it's length, feet, meters. It's going to end up 35.4 meters. We can spell it British too if we want. Meters. A wheelchair ramp is 4.2 meters long. It rises 0.7 meters. What is the angle of inclination to the nearest degree? So angle of inclination, that's like the incline. So again, that one, like elevation, is the one that's going up. Angle of inclination. So we have a wheelchair ramp. So a ramp is an incline, right? So that's going to be our hypotenuse. Right? It's 4.2 meters long. It rises 0.7 meters. What is the angle of inclination? So here's our right angle. So here's the ramp. Our angle of inclination is this one right here. We can't see this again. Here's the ground. Say we have a door that's elevated. Okay, a ramp is going to take us from the ground up to the door. If it goes up 0.7 and the ramp is 4.2 meters, here's our right triangle. The angle of inclination would then be here. Okay, which is exactly what we have. We just have it flipped the other way. Okay. So we're trying to find an angle, so we're going to use one of the inverse trig functions. So here's the angle in question. 4.2 is the hypotenuse. It's across from the right angle. 0.7 is across from the angle in question. So it's going to be opposite. Opposite hypotenuse is sine. And again, we're using inverse sine because we're trying to find the angle. So the inverse sine of the ratio, 0.7 over 4.2, will give us the angle theta. So inverse sine of 0.7 divided by 4.2. This is 4.2. That gives us an angle measure of 9.6 degrees, which makes sense because if your ramp is too steep, someone in a wheelchair will just slide down. So having a small angle of inclination makes sense for that problem. All right, number 6. Okay, number 6. So a person flying a kite has released so here we have a kite. Okay, a person flying a kite. So here's our kite. Okay, the string is 167 meters. Okay, the string makes an angle of 27 with the ground. Okay, we want to know how high is the kite. Okay, we'll call that x. Okay, we have two questions. How high is the kite? And then how far away is the kite horizontally? So let's say, how high is the kite? That's x. So that's going to be opposite. 176 is our hypotenuse, so we're going to use sine. So sine of 27 is going to equal opposite, which is x, over hypotenuse, which is 176. We want to get x by itself, so we multiply both sides by 176. They cancel, we get 176 times the sine of 27 equals x. So 176 times the sine of 27, 79.9 degrees. Okay. How far away is the kite horizontally? So let's call that y. Okay, y is next to 27 degrees, so that's going to be the adjacent side. So adjacent and hypotenuse. So we're going to use cosine. So cosine of 27 is going to give us y over 176. Multiply both sides by 176. Okay, so we get 176 times the cosine of 27 equals y. So that's 176 times the cosine of 27. That's going to give us 156.8 degrees. 156.8 degrees is y. Okay. I mean, not degrees. These aren't degrees. I don't know why I'm putting degrees here. These are lengths. So it's just equal, this meters. We weren't solving for angles. We're solving for meters. So 79.9 meters high above the ground, and then it's 156.8 meters vertically. I mean, horizontally away. It's 5:40. I'm a little tired. Haven't eaten since 5:30. It's been 12 hours since I've eaten. Need sugar. Right. Tara leaned a 17-foot ladder against the house. So again, we have a house. We're leaning a ladder on the house. Imagine this in real life. If you struggle, if you're struggling to visualize it, right? The ladder's not laying on the ground. It's not laying straight up and down on the house. We're leaning it against the house. So that's our hypotenuse. Here's our ladder. It's 17 feet long. Okay. So here's our right angle. The bottom of the ladder is 8 feet from the house. So 8 feet from the house. How high up the side of the house is the top of the ladder? Right. So here's our right triangle. Right? If we have two sides and we want of a right triangle, we want to find the third side of a right triangle, we're going to use the Pythagorean theorem. Okay, so a squared plus b squared equals c squared. So the two legs of our triangle are x and 8. So we're going to do x squared plus 8 squared. And that's going to be equal to the hypotenuse squared. Okay, so we have x squared plus 64 equals 289. We subtract 64 from both sides. We get x squared equals 225. We take the square root of both sides. X equals plus or minus 15, but we can't have a negative length, so it's just going to be positive 15. Okay. Number 8, if the diagonal of a rectangle measures 60 inches and one side measures 48 inches, what is the length of the other side of the rectangle? So if the diagonal of a rectangle measures 60 inches, so here's a rectangle. If the diagonal measures 60 inches and one side measures 48 inches, what's the length of the other side? So again, it's a rectangle, so all the angles are right angles. So here we have a right angle. So here's our triangle. Okay, hypotenuse is 60, the legs are 48 next. If we have two sides of a right triangle, we want to find the third side, we use the Pythagorean theorem. So the two legs squared added together equal the square of the hypotenuse. So that's going to be x squared plus 48 squared equals 60 squared. Okay, x squared, so 48 squared, that's not one I have memorized. is 2,304. Okay, then this one's going to be 3,600. All right, 6 times 6 is 36. You add in 2 zeros, and you got 3,600. So 3,600 minus 2,304. So minus 2,304. We get x squared equals 1,296. Okay. And the square root of 1,296 is 36. So square both sides. Again, we get plus or minus 36, but we can't have a negative length, right? So it has to be a positive number, so it's going to be 36. So x equals 36 inches. Okay, number 9. The size of the screen of a television is given by the length of the diagonal of the screen. What size is a television screen that is 21 inches wide and 16.2 inches high? Okay, so again, we have television screen, diagonal. That's what we're trying to find. It's saying that it's 21 inches wide, 21.6 inches wide, and 16.2 inches high. So again, we have a right triangle. If we have two sides and we want to find the third, we need to use the Pythagorean theorem. So the two legs are 21.6 and 16.2. So 16.2 squared plus 21.6 squared equals x squared, which is our hypotenuse. So 16.2 squared is 262.44. 21.6 squared is 466.56. Okay, those added together, we get 729 equals x squared. And if I remember correctly, that's 29, right? Or 27? 27. So again, it's plus or minus 27, but we need a positive length, so it's just going to be 27 inches. 27 inches. Okay, number 10 then. Okay, in triangle MNO, the measure of angle N is 90 degrees, NO is 27, MO is 38. Triangle XYZ is similar to triangle MNO, where vertices X, Y, and Z correspond to vertices MN and O, respectively. And each side of the triangle XYZ is 1/2 the length of the corresponding side of triangle MNO. What is the value of sine Z? So first thing we should do is draw them out. Right triangle, because N is 90 degrees, so MNO. Our other triangle is going to be, it's half the size. It's going to be XYZ. And it tells us what corresponds, right? MNO, so X, Y, and Z correspond with MN and O. Okay, N is 90 degrees, NO is 27, MO is 38. Okay, we want to find the sine of Z. Okay. So we can either find so sine is opposite over hypotenuse, so we can either find the ratio of the opposite side over the hypotenuse, or we can find the angle measure and plug it in to the sine function, and that'll tell us what the value of sine Z is. The easiest way is to find the angle. Okay, so we know there's similar to triangles, so we know the sides are proportional, and we know that the angles are congruent. Corresponding angles are congruent. So we know angle O corresponds with angle Z, so we know angle O is congruent to angle Z. So if we can find the measure of angle O, we can find the measure of angle Z, which we can then put into the sine function. Okay. So let's try and find angle O. Okay, well, 38 is our hypotenuse. 27 is adjacent. Right? So we're going to use cosine here. We're solving for an angle, so we're going to use inverse cosine. Okay, so the inverse cosine of the ratio, we input the ratio, which is 27 over 38. Okay, and that's going to be theta. So the inverse cosine, 27 divided by 38. Hold up, I hit the wrong thing. 44.7. So we know angle O here is 44.7. Since these are similar triangles, we know the measure of angle Z is also 44.7. So if we want to find the sine of Z, all we're doing is going to do sine 44.7. We plug that into the calculator, and we get 0.70, 0.70. Okay. The other way we could have done this, okay, is we could have, there's lots of different ways. Okay, we could have divided by 2 first. So 38 divided, right, it's half. So 38 divided by 2, this is 19. 27 divided by 2, that's 13.5. Okay, then we could have done the inverse cosine of 13.5 over 19. 13.5 divided by 19 is the same as 27 divided by 38, so that would have given us the same answer, right? Because we would have been inputting the same ratio, even though the numbers were different, the ratio would be the same. So we'd input that, and we would have got 44.7. Then we could have plugged that in for sine. The other way we could do it is the Pythagorean theorem. So if we wanted to find this, call that x. Okay, the two legs are x and 27, so x squared plus 27 squared equals the hypotenuse squared, which is 38 squared. So x squared is going to equal, or x squared plus 27 squared, 729, equals 38 squared, 1444. We subtract 729. We get x squared equals 715. And then if we take the square root of both sides, we get 26.7. X equals 26.7. Oops. Something. Could write decimal. Okay. So this is 26.7. Okay. Half of that, we get 13.4. About. Okay. So sine is opposite over hypotenuse. So if we're looking at Z, opposite is 13.4, hypotenuse is 19. So if we do that and divide by 19, we should get 0.70, which is what we got over here. Okay, we could have also done this one, 26.7 divided by 38. That's, again, because the triangles are similar, the ratios are going to be similar. So 26.7 divided by 38 is also going to be 0.70. So 26.7, which is opposite hypotenuse, divided by 38 is going to equal 0.70. Right? So this was opposite. Here was the hypotenuse. So either way you do it, we're going to get 0.70 for the sine of Z. Easiest way, though, is inverse cosine tells you that this angle is 44.7, so we know this angle is 44.7. So sine of 44.7 is 0.70. Fastest and easiest way to do it. Okay, but the questions might be a little bit different on the test. Might ask for cosine, or it'll give you different sides. So you have to figure out what to do.